So now we're going to do an example of decay. We're going to do number 4. Let's remember the decay formula, which is talking about price here, and it's talking about price each month. Because of that, I'm going to use for time month. Okay, this is the final price, or the price after each month, and then 1 minus R, which is the rate, to the power of number of months. Okay, now let's look at this. We have the initial price is 1,900, so it's a computer that loses its value every month by 4.5%. Okay, so it's 1,900. That's the initial value of the computer. Then because it loses value, that's what we use a negative, and we have 4.5%. If we divide this over 1,000, over 100, sorry, over 100 to get the decimal, we have 0.045, right? So 0.045 to the power of m. Okay. Now, if we subtract 1 minus 0.045, what we get is 0.955, right? 1,900, 0.955 to the power of m. Okay, this is for the first question, for the first exercise, number A, which write an equation that models the value of the computer as a function of time in months. That's what we did for A. B, determine the value of the computer after 3 months. What do we have to do? We just plug it in and that's it. So 3 months, 1,900, 0.955 to the power of 3. If we do that, so we have 1,900 times 0.955 to the power, third power. What do we have? So after 3 months, the value has decreased because this is actually a decay. So it's gonna, the price is less as when you bought it. If you sell it, you're gonna get less than what you had to pay when you bought it. So it's gonna be 1,654. Okay, that's the price in dollars. So that's, we have to look at this as a decay, right? It's decreasing the value, it's decreasing, it's a decay. Okay, C, after 2 years, well, that's easy, right? 2 years, how many months is that? It's 24, right? So this is just the same exact exercise, but instead of 3, it's just 24, right? And then is the price going to be more or less than than the value we get for 3 months? What do you think, guys? Well, it's gonna be even less, right? So if we use the same values we did before, we put 24 in here, we get 629. So look at that, it's the price, it's depreciating really fast, correct? And then D is the more interesting one, because they're asking, this is actually an inequality, determine the time at which the value of the computer drops under 400, right? So now the price, we want to know the price, it's going to be now less than 400, right? So what's the price now? Well, let's write the equation here. So it's 1,900, 0.955 to the power of m. We want to know how many months. This is going to be less than 400, right? Okay, so we need to have something like this. Remember, b to the x equals y, and then we we do x equals log base b of y, right? That's what we need to do this transformation, but to do this we need to base to be alone by itself, so we're gonna divide both sides over 1900. When we do that, we can cancel these zeros because it's like dividing 100 over 100, which is 1, right? This cancels out. We're going to have 0.955 to the power of m less than 4 over 19. Then we apply the log. When we apply the log is m equals log, now the base, 0.955, and then 4 over 19. We use now the calculator. We use now the calculator to do this log the base, alpha f2 is 0.955, 4 over 19, so that's 33.84. So after 33 months, after after 34 actually months, the price will be lower than 400 after 33 months. So the way we write this is for m greater or equal than 34 months. Okay, the price will be under $400. That's it. Okay, so that's it. We're done for this.